Hi there, we're going to talk a little bit about lesson 12.6. We're going to do scientific notation, and this is just going to be day one. So today's just really an introduction to scientific notation. So the first thing that you need to know is, what does a number that's in scientific notation actually look like? So for this part of your lesson, you're going to want to jot down these notes. A number is written in scientific notation if the actual number part is somewhere in between 1 and 10. So what that means is that it is actually allowed to be equal to 1, but it does have to be less than 10. So as long as it's between 1 and 10, you're good to go for the first part of the number, and it's going to be multiplied by a power of 10. So we're going to have some number between 1 and 10 times 10 to some exponent. So for example, this is just kind of show you an easy one. So we start off with the number 700. 700 we could rewrite as 7 times 100, which brings us to right here, which means this number 7 is going to represent our number that's in between 1 and 10. And then we're going to multiply it by our power of 10. And 100 is actually 10 to the second power. So 7 times 10 to the second power is in scientific notation. This number that's written as 700 right here is in what we call standard form or standard notation. For these examples across here, we're going to go one by one. And the first one that we see is 56.29 times 10 to the 12th power. And I want you to take a look. This first part of your number, this 56.29, is that in between 1 and 10? Because it is not in between 1 and 10, this automatically is not written in scientific notation. Our next example that we have is 0.84 times 10 to the negative 3 power. So 0.84, this number is not in between 1 and 10, so therefore this number is also not written in scientific notation. Your next example is 6.11 times 10 to the 5th power. Two things to check: is your first number somewhere in between 1 and 10? And 6.11 definitely is. The second thing to check is your exponent, is your second part a power of 10 to a power? And it actually is. So this one is, yes, written in scientific notation. Your last example is 3.42 times 10. So the first part here, we have 3.42, which is a number between 1 and 10. We do have it multiplied by 10 to a power, and it just so happens that this power is actually 1. We just don't have to write it. So this one is also, yes, written in scientific notation, because this is 1 to 10 times 10 to some power, which is 10 to the first power. For our next group, we're going to go ahead and write some numbers in scientific notation. So when we do this, we're going to go ahead and take a look at the first one. Your number is 5,240. So your first job is to figure out, right now the decimal is back here at the end. We need to go ahead and move that decimal somewhere in this number so that we create a number that's between 1 and 10. If we moved it to right here at this spot, we're looking at 524, which is not going to work. If we move it here, we have 52.4. And if we move it right here, we actually have 5.24, which is going to work for us. So the first part of our answer is going to be 5.24. And then you can put the 0, you don't have to. It's totally optional here. You're welcome to leave it since it was there. And then we have to figure out times 10 to what power. Since we are making this number smaller, we've moved it to the left, we would need to move this decimal point to the right to turn it back into the number that it started in. In fact, we'd have to move it 1, 2, 3 times. So our power is going to be 10 to the positive 3. You're going to have positive exponents if you have numbers that are greater than 1. And you're going to see on the next example that's already visible for you that you're going to have negative exponents when you have a number that is less than 1 to start off in standard notation. For the next one, go ahead, write down 0.000672. Again, we want to make our first number to be a number between 1 and 10. So we're going to move the decimal point right here in between the 6 and the 7. So when we move it here, we're going to have 6.72 is going to be our number. And then we need to count. We need to move it 1, 2, 3, 4 spots. And Mrs. Grabner messed up on this one. So it is going to be 10 to the negative 4 power, because we would need to move it back 4 spots to the left to put it back into standard form. Noticing that this number starts off as less than 1, so therefore our exponent is a negative number. In our next example, we're going to do 5.4 million. The first thing you need to know is that when we write out 5.4 million, that means 5,400,000. So we can write it out like this. In doing this, we're going to need to make this into scientific notation. So we need a number between 1 and 10. So I'm going to put my decimal point right between the 5 and the 4. So I'm going to have 5.4. I need to make this bigger, so it's going to be a positive exponent. And I'm going to move it 1, 2, 3, 4, 5, 6 places to the right, which is going to make my exponent to be a positive 6. So in scientific notation, 5.4 million is 5.4 times 10 to the 6th power. The last one we'll do like this is 0.0047. We're going to move the decimal point in between the 4 and the 7. And we're moving that decimal point 1, 2, 3 places. Since my standard form number is less than 1, my exponent is going to be a -3, so that it keeps it a smaller number. So that's how you go from a standard form to a scientific notation. The last thing we're going to do is talk about writing in standard form. So again, thinking about this one, with positive exponents, we need our number to end up being greater than 1. Positive exponents will cause us to move our decimal point to the right. Negative exponents will cause us to move our decimal point to the left then, therefore creating numbers that are smaller than 1. So my first example you're going to write down is 4.5 times 10 to the 7th power. So I'm going to go ahead by writing down the 4 and the 5, and I'm going to kind of put my pencil there in that spot, and then I'm going to make 7 spots to the right. 1, 2, 3, 4, 5, 6, 7. This is where my decimal point now goes. To fill in all those spots that are empty, we need to put in zeros as placeholders. So we go ahead and we put in those zeros, and you'll get exactly what I have matching up here. The other thing that you should do is go ahead and put in commas. So you count 1, 2, 3, and then you place a comma. 1, 2, 3, and then you place another comma. In the next example, we have 5.261 times 10 to the -8 power. This -8 tells me that my number is going to end up being a number less than 1. So I go ahead and I write down 5261, and I temporarily put my pencil there. And I need to go 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8 spots to the left. And that brings my decimal point back here. So I'm going to put my decimal point, and because it's less than 0, or less than 1, I am going to put a 0 out front just to realize and let somebody know, hey, there's a decimal point coming. Always put that one. So you have here 0.00000000 5261. So clearly a number that is drastically less than 1. So that's your introduction for scientific notation for today, talking about going back and forth between standard and scientific notation form, and also trying to figure out if a number is in scientific notation.